check that out. Anything jump out to you? Any important points seem to go with other important points? I mean, anything? What did you see, Hunter?
And the slope of the original graph 0, it's just the point on the x-axis for the derivative.
Okay, so that's a pretty important one. So when slope of graph is 0, then the derivative graph, could you say that again? Derivative graph does what?
There's points on the x-axis.
Hits the x-axis. I'll just put on the x-axis. So, or you could say it's an x-intercept. That is a great observation. I think there's a few others. What else could you observe from that little activity? That's a really important one. There's a couple of others.
The cubic function is going to be a quadratic.
That's true. Yeah, if you know the power rule,
Yeah.
that should make a lot of sense. And I agree with that, although I will say we want to, what you said is 100% true. We want to stay away from using that as the way that we graph things, because we're going to be able to find some things that don't really seem to fit the lovely polynomial thing. And if that's our reasoning, we're going to get a little bit lost in certain situations. But what you said is 100% true. So I'm not going to write that down because I don't want that to be the big takeaway. But what you said is true. Anything else? Any other observations? You're going to just leave it up to Hunter
When graphing,
and Reese.
when graphing your derivative, you keep your original x value and then the slope of that point is your new y value.
Yeah, okay, now that's pretty good. So, So slope of, we'll put original graph gives us the y value of the derivative graph. And I think you can take the just almost anything we're going to do with these graph sketching things that we're going to practice with today, almost anything we're going to do here, I think could be summed up with these two statements. And really the second one is the more general one, so you could almost say that one, but that one is almost too general to be of use at times. But it's very true and I think very useful as far as how we're going to graph these. And we can go back to that little demo if we need to, but I'd rather us practice a little bit. And I don't know if it's a Monday morning, or I don't know if you did the intro, or maybe the intro didn't help. I don't know. But maybe I'll do this first one here with you and give you some hints about how to do this. I have a suggested procedure here, and we'll see how this all goes. So we're going to do just a handful of examples today. It says, remember that f prime describes the blank of f. What do you think goes in the blank? Okay, yes, derivative, but let's think about graphs, graphical features. The slope, right? Slope, yeah, so f prime certainly does mean derivative. F prime describes the slope of f of x. Now, the activities we're going to do here today are, I don't know, it's like, it's once you see them, like once you see it, it's actually pretty easy. But up until the point where you don't see it, like if you're having a hard time seeing it, they can be very difficult. But the principles that were mentioned, that we're going to be graphing the derivative or the slopes with respect to x, I think that's probably the key here. So let me give you a suggested procedure, and I'll show you how that applies to this first one. Here's my suggestion. Number 1, locate horizontal tangent lines of f of x. So let's do that. So we got f of x there on the left, and we're going to sketch this f prime graph on the right. So on the graph on the left, how many horizontal tangent lines do you all see? 2 of them. And would you guys agree with me that they are located, oh gosh, like right about here and right about there?
Yeah.
So that's like negative 1.5-ish and negative 0.5-ish. Not exactly right there, but pretty close. Okay, so here's what we do with those. These become x-intercepts on the graph of f prime. Those become x-intercepts on the graph of f prime. And this goes to Hunter's original idea. What's the y value of an x-intercept? 0. What's the slope of a horizontal line? 0. So anytime the slope of f is 0, aka f prime is 0, we are going to put zeros, aka x-intercepts, on our graph of f prime. So I would plot this out as zeros roughly here and roughly there. Does that make sense? I think it's really important. In my opinion, I think it's really important that you do it in this order. Graph the zeros of f prime before you do anything else. Okay, then, this is not really going to apply to this one, but make note of places where f prime does not exist. So what would I be looking for on the graph of f that would indicate that f prime doesn't exist?
Vertical lines.
Vertical tangent lines?
Yeah.
Yep, vertical tangent lines is one. What's another one? Yeah, like a vertical asymptote of some kind? Sure, that'd be another one. What's the third one? Yeah, like discontinuity. Yeah, all these things you're describing are discontinuities. What else? There's one more thing one more graphical feature that would cause f prime to not exist. If f had a...
Jump.
Say again?
Jump.
That's another point of discontinuity. It's true, for sure.
Oh, a sharp point.
A sharp point, right? Remember the absolute value looking thing, sharp point? So if I've got any of those features, I need to make a mental note of that. And you can see that on this graph, there don't appear to be any of those. So we'll skip that step. And then the final step is this. Figure out where f prime is either positive or negative. And that's how we'll finish out our graph. Okay, so far I only have 2 points on my f prime graph. I'm going to figure out the rest of them by doing step 3. I'm going to break this down into little chunks for you. So on the red chunk right there, would you say that the slope of f is positive or negative? Positive, I agree. And therefore, f prime must be positive. Where do positive outputs show up on a graph? Above the x-axis. Well described, well said. And so I would say for that stretch, we'd be looking at something like this. And I know that I'm heading towards that x-intercept. So my graph has to go there, right? Because I know that f prime is 0 at that point. So I've got to come from above towards that x-intercept. Well, how about on the green part? Is f prime positive or negative?
Negative.
Because the slope there is negative. Where do negatives show up on a graph?
Below the x-axis.
That makes sense? But I know that I've got to head back to my other x-intercept, so I can't do this. That doesn't make any sense, right? I know that other point is actually on my graph of f prime, so I've got to go here and I've got to loop back up to that x-intercept. Makes sense now why I graph the zeros first, because you know where those points are, so you got to go there. And then finally, how about the lovely blue part? F prime there would be positive. And positives show up where? Above, yep. So we'll just go above here and go off into the distance, something like that. Okay. Do these graphs have to be perfect? Like a computer made them? No, they don't. I'm essentially looking for the elements in my little steps there. I'm looking for those 3 elements. Do you have the right zeros? If so, great. Do you have the places where maybe f prime doesn't exist? Great. And do you have the positive or negative portions correct? That's fine. So if you had something like this red graph, do you see how that red graph is just as good as my blue graph? One a little bit further down there, but all the other elements are exactly right. You could do this orange graph, and this orange graph would be just as good. So I'm not going to get out the ruler and say, Jackson, I'm sorry, you were ½ millimeter off, -1. We're not going there, right? If you got the right elements in place, we're in good shape. Okay, so there's another one for you guys to practice. If you would flip over to the next page, if you would try that one, please. Feel free to compare and check with each other. We'll try to wrap this up with our final one here in a couple minutes. Giving you a little bit of extra repetition. I'd rather you draw it over there just so we don't get super tangled up. But if you can, Merrick, if you can see it, that's fine. Like on quizzes and tests normally, like if I were to test you on this concept, I would give you that whole separate graph and I would wish and hope and pray that you would draw it on that other one instead of on top of the other one. Just for my own reading. Okay, just looking around, I'm seeing we're getting some solutions here. This is good. You guys are picking up on this pretty well. I think this is encouraging. Okay, so let's look at this. I went ahead and pre-graphed a couple of important points. What do all those purple points go with?
Zeros.
Yeah, those are zeros. Those are places where F on the left has horizontal tangents, and so therefore where F prime is 0, right? I graphed those ahead of time, and I think you really want to graph those before you even think about anything else. Okay, so then from here on out, there's no points of non-differentiability because there's no sharp points or points of discontinuity. And so I'm just going to be going through and asking myself, where is F prime either positive or negative? So I'm going to go from left to right. Hopefully that makes sense. So from left to right, the first interval I come to is right here. Is F prime positive there or is it negative?
Positive.
It's positive, right? Because F is increasing. It's going up. And so we need to be above the x-axis on that interval, like so. Does that make sense, right? So like right in here, we're saying that slope of F is positive, therefore F prime is positive. And positive outputs are always going to be above the x-axis. Make sense? This needs to be logical. It can't just be some procedure that your teacher showed you. How about this yellow interval? F slope is negative, so F prime is negative. Agree. And where do negatives show up on a graph? Below the x-axis. But because I graphed all my zeros ahead of time, I know that I've got to point back to that 0 right there. So I got to curve back up and hit that. Okay. Maybe I'll do another one or two of these the slow way, then we'll go a little faster. How about the orange interval? F prime is positive, right? Because F is increasing. F is going uphill. And so where do positives show up on the output of a graph? Above. Good. So we go above, but then we do have to loop back down to that 0. And then are you guys okay with the rest of these? Essentially the slope of F goes from negative to 0 to positive, and then back to 0, and then we finish with a little negative there. So again, that's a rough sketch. The term I use for this is sketch. It's not a computer-generated graph by any means, but it is your best effort at getting all the important parts correct. Okay, any follow-ups? Are there any confusions there? So if any of you have been kind of following the way of thinking that Reese mentioned earlier about, hey, the derivative of a cubic is a quadratic, et cetera, this next one, at least part of it might generate a little bit of stress, and I'm not trying to stress you out, but you might see where that way of thinking might fall a little flat at times, because this is neither a cubic nor a quadratic. I mean, that part on the right sort of looks like quadratic-ish. You can tell it's piecewise, right? It certainly looks piecewise. And notice it says F has a sharp point at x equals 4. I'll try to always make those sorts of things clear. So let's go ahead and go through our process together here. The first thing we want to find is horizontal tangent lines of F. Do you see any of those?
At 5.
Yep, at 5 it looks like we've got a horizontal tangent line. I could even sketch that in, that horizontal tangent line would be like right about there, and it looks like that's happening at 5. So what's the slope of a horizontal line? 0. So f prime would be 0 there. So I'm going to put my x-intercept here. Would you all agree with me that that is going to be the only x-intercept on my graph of f prime? There's no other horizontal tangent lines anywhere else. Okay? Now, remember what I said? We haven't done this yet. Make note of any points of non-differentiability. Where do you see a point of non-differentiability?
X equals 4.
At 4. And I even tried to emphasize that over here by saying there's a sharp point. Make note of that. We'll do that here in just a little bit. And then what we're going to do is we're going to go from left to right. And we're going to graph the slopes as they come. So how about this orange stretch up to that sharp point?
Constant slope of 4.5.
Positive slope, right, clearly. So therefore f prime would be positive. And because it's a line, I think we could take it that far and say about 1/2. I think that makes a lot of sense. So I'm going to just come in here and say that that is a positive slope. And it's roughly at, 1/2. And then I get to that 4, right? Any guesses on what's going to happen at 4?
A linear line. No. It's going to be a hole.
There's going to be a hole. Was that you, Cole? Yeah, nice. Because f prime does not exist there. Would you guys agree with me that once I go from 4 and start working my way right, doesn't the slope remain positive? But doesn't it get a little bit bigger? It gets steeper, doesn't it? So this is all slope equals 1/2. What would you say this slope is over here?
2.
Yeah, 2-ish, steeper, right? So what if I did something like this? I come up to about here, roughly around 2. I put another open circle, because remember, at 4, f prime doesn't exist, so you get a double open there. And then I would say that on the green stretch, in general, the slope is positive or negative. So it remains above. But then, once you get past 5, once you get to this amazing purple interval, doesn't the slope of f go negative?
No.
And negatives are where? Below. So it looks something like that. It would maybe be linear over there. It's hard to say. Again, we're just sketching it. So based on the intro activity in this is just kind of an intro. This is a warm-up. Over the course of the next couple of days, we'll keep practicing these. And hopefully you'll get really, really good at them before Thursday. Hope you have a great day. I'll get your quizzes graded for you and in the grade book, and Lord willing, back to you tomorrow. So have a good rest of your day.